All right, so we kind of talked about this a little bit before everybody joined in about how this will be structured. Most of our meetings should be about 20 minutes-ish of going over some coding challenges. My plan is to come up with some coding challenges, one easier, one medium, and one harder. And so they should kind of tie into each other, so that once you've done the easier one, you can use it to do the harder one, and so on and so forth. So we'll do 20 minutes of like going over the previous month's exercises. So today I'm just going to introduce the one that we'll talk about in February. And then the rest of the time is kind of a deep dive, which just means going over some new technology, new framework, new library, or just if someone has something that they just want to talk about, some project that they've been working on that they just want to show, that's welcome as well. So today, since we didn't really have much of an agenda planned out, today we're going to take a look at SolidJS. Has any of you heard of SolidJS before or used it to any extent? Okay, so for you people who have had some experience with React, it's pitched as a React alternative, which is a little lighter and well, we'll let the website speak for itself. But actually, before I jump into that, let's I'll show the coding problems first for next week. Let me share my screen here. All right, can you guys see my screen? Awesome. So we have a JSON array with characters. They have a name, they have hair color, they have whether or not they're wearing a hat, and whether or not they're wearing glasses. After looking at some of these names and some of the attributes on them, you may have an idea of where this is from. This is the guess who characters. I don't have all the attributes listed here, so I just picked a few, and I literally just looked at the images and typed them in. So if yours have different names, if you know a set, you see an image online that has a different set of names, like sometimes Frank is called Franz, or their attributes are slightly different, they usually try and keep relatively consistent. But the goal is essentially to kind of come up with a guess who solver. And what I mean by that is see if you can come up with some sort of algorithm that gives you an idea of what is the best guess to make. And that's not an easy problem. So I'm kind of breaking it up down into some smaller steps. So these are the first three problems. We're not going to complete that whole activity in this first month. So it'll probably take a couple months to go through all of it. So the first one is just find all the characters that have blonde hair. The second one, which is and then when I say easy, medium, hard, I don't mean that easy is super easy and hard is super hard. They're just relative to each other. So sometimes a harder problem might be harder than the previous week or something. The medium one is create a function that compares two characters and returns the differences between them. So what that means is if I take Tom and Susan, for instance, besides the name, obviously the name is different, but their hair color is different. So we would create an object that has a property hair color and say this hair, or we could either do, actually, let's do it this way. Instead of saying, we'll just give it an array of the attributes that are different. Does that make sense? So if I say Susan and Tom, hair color is different. They're both not wearing a hat, so that's the same, but Tom is wearing glasses and Susan isn't. So the result of Tom and Susan should be an array of hair color and wearing glasses. So that should be the result of that one there. And the last one is use this function from the previous exercise to compare each character to every other character. So we want to know all the differences between all the characters and how they differ to each other. So does anyone have any questions on those exercises today? Do they make sense how they're worded?
So for the hardest one, you want to see, for example, if Tom is the one that you're comparing everyone to initially, then Tom is different from Do you want like an array for Susan and then an array for the next person, everybody within an object of Tom, listing sort of all their differences?
Yeah, that's true. So what you'll probably need to do, it's slightly different from this one, because here, when we compare Tom to Susan, we return that array there. It's probably a good idea for us to return the two things that were compared as well. So you're kind of going to need that in here. This array needs to match what are the two things that I compared and what are the differences. So basically we want Tom compared to all the other characters, Susan compared to all the other characters. Obviously, because you've already compared Tom to Susan, you don't need to do that again. So just kind of go through and compare all the characters to each other and see how they're similar and different. So I will.
For each character, we want the similarities and differences to every other character.
Mm-hmm. Yep, that's right.
So for each character, there'd be a list of other characters and differences.
Right. I guess one way you could see this is actually let me give you a little better structure to this. That's a good question here. So what we're looking for in here is just an array of if I compare Tom and Susan, we had what we had before. We want an array of the attributes that are different, and these are strings more specifically. Do you need me to make this font size a little larger, or is that readable? So the function just returns an array of the attributes that are different. This one instead, though, needs to have first of all the characters that are that were there. So you could say characters, and then give an array of Tom and Susan. We're going to assume, of course, I didn't put IDs on these characters, but their names are basically their IDs, right? So you can identify them by their name. So we want an array of, an array of objects. I forgot to write that in object there. You have the characters that were compared to each other, and then their differences along with it. So diff, and then this would be the same as that. So you would do that for all the characters. You would go down and create an array of all the characters compared to each other and the diff that they have. So what I'll do is I'll post this in the JavaScript channel in Syracuse.io. We'll also have the recording there, and anyone else who wants to join who missed today's session can pick it up, and then we'll just kind of go through and see the different solutions that you guys came up with. And there's not necessarily one right answer. I'll also say, admit that I have a bit of an ulterior motive with this particular problem. I have a use case at work that needs more or less an answer to this problem. I didn't obviously put the actual problem in here, but it's a very similar sort of problem that needs to be solved. So you guys might be helping me out at work if you come up with some solutions to this. All right, so let's jump into SolidJS now. So I haven't done much with Solid either, so we're just kind of gonna do it together. We'll start with just kind of going to the SolidJS website and use the Getting Started guide here. Actually, let's go to the homepage first and see what SolidJS says about itself. So it says simple and performant reactivity for building user interfaces, performant, consistently Tom's recognized UI speed, memory utilization benchmarks, powerful, it uses JSX, which is why it's kind of like a React alternative. Pragmatic, sensible, and tailored API, productive, ergonomics, and familiarity. So I think one of the features that it has is kind of like hooks. It took hooks from React, but then had its own spin on it. So I think that's one of the key differences between it and React. Comes with TypeScript support out of the box. I'm not going to focus too much on TypeScript in these meetings. This is JavaScript meetup after all, but we may look at it a little bit. Uses Vite as the build tool. For those of you who don't know, Vite is a build chain that was particularly built for Vue, but it's now been kind of opened up and used for pretty much any front-end framework or library. They say that it's a framework built in Go, and they won't actually tell you that on the website, but it actually uses ES-Build under the hood instead of Webpack. So that's primarily, it's just a kind of wrapper of tools around ES-Build. That's what that is. So this says it's familiar and modern. Solid stands on the shoulders of giant, particular React and Knockout. So I've never heard of Knockout before. Have any of you heard of Knockout before? Okay. Says if you've developed with React hooks before, Solid should seem very natural. In fact, more natural, as Solid's model is much simpler with no hook rules. So yeah, that's the key thing. It says that they use hooks, but a slightly different twist on it. Every React component executes once, and it's the hooks and bindings execute many times as their dependencies update. So it has the same philosophy as React with unidirectional data flow, read-write segregation, and immutable interfaces. So for those of you who are more familiar with kind of the other frameworks or libraries that are out there, there's a pattern that's kind of developed and almost standardized in the world of front end of you want to kind of model your view using JavaScript data, right? So you want to model the things that you see on the screen using JavaScript objects and arrays. And then you want to be able to modify those arrays and objects programmatically, and then have that modification just change the view for you. Instead of going in manually and updating the DOM, updating different things, like in the jQuery world, right? That's how you would do things. You would find an element and change its attributes or change its content. Instead of doing that, you just change your data and it just updates the website for you. But it's not necessarily a good idea to just change it. What's it called? It's not a good idea to change it in place, usually. You want to have this more control around it. You want to render it from the data. Your UI dispatches events. Those events go through some other thing called like a store usually, and then those things update your data and send it back. So you have this like unidirectional data flow. That's what this is referring to. So you've probably heard of Redux. Redux is one of those things that that enforces that unidirectional data flow in a React application, or at least gives you some guidelines for how to do it. The idea of unidirectional data flow mostly came from a language called Elm. That's where it originated. Elm isn't super popular nowadays, but that's where it came from. Fine-grained reactivity means you do more with less. So Solid's built with efficient reactive primitives. So this is the thing that Solid introduced. It's these things called reactive primitives, which truthfully I don't really know what that means. But we'll dive in and see what, I presume since it's something that they're so proud of, we'll see it pretty early on in the examples. So this says it's barely slower than vanilla JavaScript. Benchmarks, of course, are not always the most useful things, but it, compared to JavaScript, if this is a JavaScript alternative, if this is a React alternative, that's basically twice as performant, maybe it's worth looking at. Fully loaded with all the features, fragments, portals, context. So these are things, if you've looked at React and gotten more into, these are pretty much all familiar to you: fragments, portals, context, suspense. Some of these are actually next-gen features that aren't official yet. Suspense is, I think, still in beta. I don't think it's really officially out yet. So, all right, so let's jump into trying it out. Let's use the getting started one. Okay, try Solid. So by far the easiest way is to try it online. They have a REPL online, or you can use Code Sandbox. We're going to actually just try and install it and do it locally. So I just had this little directory that I'm using for our JavaScript meetup stuff. for those of you who know Node, obviously, I'm just doing a little npm init to allow me to install npm packages in a node modules folder in this folder. So that's all that's happening there. So that created a little package JSON, which allows us to manage the dependencies on my computer here. So here we'll do npx. Actually, ironically, this is going to create another folder with an npm or package JSON. So that was kind of unnecessary. We'll do that anyway. Put it in JS Meetup. So npx is running a script instead of npm. And we'll go into here and see what they got. cd myapp npm I npm run dev. So npm I is installing all the dependencies, and we run dev. Let's take a look at what's in this package JSON file. It's pretty minimal. It's using Vite as a build tool, so you're not seeing any webpack config or anything crazy. The Vite config is pretty minimal as well. It's cool. All right, we'll do npm. Oops. 481 milliseconds. Let's take a look at what that did for us. Okay, so I have a basic solid app. I'm going to move this over to the other screen here. Right. And it says edit app.js here. So we can just say hello world in here, save it, and all right, that didn't re-render. Okay, so for some reason hot module reloading doesn't seem to be working very fast or at all, one of the two. Let's continue anyway. So components are functions that accept a props object and return JSX elements, including native DOM elements and other components. They can be expressed as JSX elements in Pascal case. So same as React. Components are lightweight in that they are not stateful themselves and have no instances. Instead, they serve as factory functions for DOM elements and reactive primitives. Okay, so I think what's no, I guess not. Solid's fine-grained reactivity is built on 3 simple primitives: signals, memos, and effects. So these are new topics. Together, they form an auto-tracking synchronization engine that ensures your views stay up to date. Reactive computations take the form of simple function wrapped expressions that execute synchronously. So here's an example that kind of looks like hooks, but they're called signals instead. So you get an array back of first and set first, and then you get last set last signal. So this puts the first and last together concatenated in a string, and it's using an effect to do that. Think solid. So these are the premises of the way of thinking. Declarative data is the practice of tying the description of data's behavior to its declaration. Vanishing components. It's hard enough to structure components without taking updates into consideration. Solid updates are completely independent of the components. Component functions are called once, then cease to exist. Components exist to organize your code and not much else. Interesting. Truthfully, I don't really know what that means until we try and dig into it a little bit more. Precise control and predictability make for better systems. You don't need true immutability to enforce unidirectional flow, just the ability to make the conscious decision which consumers may write and which may not. Okay, so this, to me, sounds like they have a more flexible viewpoint of immutability, whereas in Redux, you can't do it at all. I believe Solid kind of uses mutation to achieve some of this performance gains and reactivity. Simple is better than easy. A lesson that comes for hard for fine-grained reactivity, explicit and consistent conventions, even if they require more effort with it. Okay. So web components is first create first-class citizens, server rendering, no compilation. So you can do it again. You can do this with JavaScript too. You don't really need to use JSX. They're using template literals to achieve that. And that's just where you have a function with these backticks, and the stuff that's in the backticks actually gets sent as arguments to the function HTML. That's what's happening here. React's way of doing it is using these like render functions. So, all right. Learn solid. Nope. Okay. I was getting started. Let's go to reactivity. Nope. Tutorials and all that. Okay. Huh. All right. This looks like it's more helpful. Introduction with a tutorial. And we can actually just kind of do it right in here. Each lesson in the tutorial presents a solid feature and a scenario to try out. Okay. Let's continue. JSX. JSX is HTML-like syntax. If you're doing React, you already know what it is. It doesn't have void elements. JSX must return a single element, which means if you want to return multiple things, you use a fragment, which is these guys here, empty tags. JSX doesn't support HTML comments or special tags like doctype. It does support SVG. Let's try copying some SVG right into our components. So let's put this in the place where that SVG is. There it is. Okay, so nothing necessarily new. This is all familiar if you've been doing React before. We'll take a look at this render function now. This render function, okay, is basically the thing that attaches it to the node. So this would be the base render of React, the root of the application. So that's not necessarily anything new. Looks like I was supposed to put this somewhere else. So let's move it to the right place where it says to put it. So this used to say SVG here, and this is supposed to just be inside there. Yeah. So you can use JSX right inside of a JavaScript expression, just put it in parentheses, and it returns an actual solid element. Nested components. So we wrap them in a fragment if we want to show multiple things. When the parent component first renders, it'll execute the next function. We'll call it again. Okay. Let's add our nested component to a wrap. So do we have a nested component, or do we have to create one? Import nested is what it's saying. So they've created a nested component for us. We just need to import it. And then we need to put it inside of our application, but we need to open up a fragment in order to do that. And then we put our nested component directly inside of there. I think they used the backslash. All right, so we see this is a header and this is a paragraph underneath here, which presumably is coming from this nested component. All right, signals. This is where it gets fun. Signals are the cornerstone of reactivity in Solid. They contain values that change over time. When you change the signal's value, it automatically updates anything that uses it. To create a signal, let's import create signal from SolidJS and call it from our counter component like so. Okay. We already imported create signal. We'll put it inside of here. Const count, set count is equal to create signal 0. 0 is the initial value of the count. In this lesson, we'll use JavaScript's set interval function to create a periodically incrementing counter. We can update our count signal every second by adding this code to the counter component. Put it right underneath there. And each tick we read the previous count, add 1 and set the new value. And solid signals also accept a function form where you can use a previous value to set the next value. That's pretty cool. Let's try that out later. Okay, so this should be counting once every second. But for some reason, maybe I need to reload it. No, okay, that's not working. We take the count, we add 1, and we're doing that. Okay, what am I missing here? Finally, we need to, oh, okay. We need to read the signal in our JavaScript code. It's just hard-coded as 0 there. So count. All right, so there it is, counting every second. So this is very similar to hooks at the moment. I don't believe hooks have this syntax here, so let's give that a try instead. This is saying that I could take the previous one and then just kind of increment it. That's cool. So instead of giving it a new value, if it sees that it's a function, you have a little bit more control over what that function, how it controls it. Not sure why it's breaking now. What did I do differently? Why is that breaking? Solid signals accept a function form where you can use previous value. Huh. Well, that doesn't seem to be working in here. Do you guys see any issues with what I've typed here?
It doesn't have the seconds after it. Are they supposed to be there? It just ends in a semicolon.
It's working now. Okay.
Hmm.
Let's try multiplying it by 2 every time, just so we can see something different. Oh, well, obviously 0 multiplied by 2 is always going to be 0. So start at 1. There we go. So it's multiplying by 2 every time. Okay, that's cool. Instead of having to reference this variable, you can kind of just give it a function that transforms each previous one into the next one. All right. Let's take a look at effects. Effects are similar again also to how they are in React. So effect can be created by importing create effect from SolidJS and providing it a function. So let's try that out. The count is now count. Put that in there. Whenever the count changes, it will run the effect. And I believe how it's doing that, could be mistaken about this, but this function knows that inside of it is a signal. It senses that there's a signal in there essentially. And it now knows that whenever that signal changes, it should run. That's what's going on there. So to update our count signal, we'll attach a click handler on a button. Oh, maybe not. Maybe I'm wrong about that. No, okay. So this is just changing the set count. So we'll add this button that increments the count. Okay. So if I click me, the console is over here, I believe, or something. Let's see, where's the console? Output, yeah, should be there. No, okay. Where do they have the console? Over here. Okay. The count is now 0. So if I keep clicking on it, is there a way to expand it? Okay. Scroll down. It's 1, 2, 3, and 4. It just keeps incrementing based on the value of count. So let's give this a try. Let's try putting a different signal in here and just call it count 2. And say set count 2. Now I believe it still work is fine, and it's still running the effect. If I change this now to count 2 and say click me, it's not doing anything because count is changing, right? We're still incrementing count. In fact, let's prove that we're doing that. Let's put the count directly inside of here so we can see the count is still changing. Okay, so count is still changing, but count 2 is not. And so the effect is not being run because count 2 never changes. So if I were to change this one to set count 2, and make this count 2 as well, Now if I do this, this one is being changed, but this one's not, right? Because I'm not changing the count, I'm changing count 2, but the effect is now being run. So that's how the effects work. Effects senses that there's a signal in there. And then anytime that signal changes, it's running itself, it's running the effect. What's really interesting, if you start to kind of think about how that might work, usually what you get back out of a hook is just kind of like this thing. Like it'd be interesting to let's try this out. Let's see what JavaScript says count is. We'll say console.log the count itself. Okay, so it's a function, but it's probably got some extra like internals that Solid is using in order to kind of connect the effects to the signals. Not entirely sure how it's working, but there's something in there that's linking the two of them. So that's pretty cool. I think that's something that it adds on top of React. React doesn't do that, I don't believe, with the hooks. So that's kind of cool. We've seen that whenever we access a signal in JSX, it will automatically update the view when that signal changes, but the component function itself only ever executes once. Okay, so I think what that means is this guy is a function, component function. It only ever executes once, meaning it doesn't rerun this whole function. It runs this whole function, and then internally it's probably using a closure of some sort to maintain the state and only updates the DOM elements inside of it. That's different from React, where React has this like virtual DOM, and it's like diffing the whole tree and changing a whole bunch of stuff. Solid, I believe, is kind of doing a little bit more low-level stuff like actual DOM manipulation under the hood for you to achieve that performance. So let's update our counter to count by 2 by introducing a double count function. This looks very much like what we were doing before. Const double count is equal to count times 2. We can then call double count just like a signal in our JSX. Div count double count. Okay, so this one is just taking what our count is and multiplying it by 2. So in many ways, this is kind of like, in some languages or frameworks, you'll see something like a computed property or like a getter or something. Vue has this idea of computed properties, which is like, I have some state, but I want to perhaps see a modified version of the state. Something that, like in this case, doubles the state. So this is just a simple way of taking a signal, creating a new view on the state, and reacting to that instead. Cool. Memos. Okay, so this is the last one. They said effects, signals, and memos, I believe, were the 3 things, if I'm not mistaken, that we saw. Most of the time, composing derived signals is sufficient. However, it is sometimes beneficial to cache values in order to reduce duplicate work. We can use memos to evaluate a function and store the result until its dependencies change. This is great for caching calculations for effects that have other dependencies and mitigating the work required for expensive operations like DOM node creation. Memos are both an observer, like an effect, and a read-only signal. Since they are aware of both their dependencies and their observers, they can ensure that they only run once for any change. This makes them preferable to registering effects that write to signals. Okay, so if you have an effect, like previously we saw the effect, that effect was just doing a console log. If you have an effect that's supposed to actually do something, like run a fetch something from an API, you could do that. But they're saying if you want to set the state in the effect, you should use memo instead. That's what this is saying, essentially. Creating a memo is as simple as passing a function to create memo imported from SolidJS. Okay. In the example, recalculating the value gets increasingly more expensive with each click. If we wrap it in create memo, it recalculates only once per click. Okay. So we'll put this in const fib is equal to create memo Fibonacci. We're supposed to replace this line with that. So what it was, let me actually comment that out, was this, which was just a what was the thing from the previous one? I don't remember what the previous page was, but it was doing the same thing when you were taking a function and running it on that signal. This one is memoizing it essentially. Place a console log inside the fib function to confirm how often it runs. Okay. So we need to modify. Currently, it's just returning the fib function. So we need to take the create memo, replace the entire contents of it with the console log version. Okay. So every time that we click on this, it's calculating all the Fibonacci numbers, but it's only running once per click. It'd be interesting to actually see what it was before we memoized it. So here we're going to do the same thing. We'll console log calculating Fibonacci. We'll put something slightly different in there. Non-memo, and then we'll return the Fibonacci there. Let's see, close that out and comment out this one. All right, so this is the old one. Let's clear the console log first. Okay, so calculated 50 times without the memoization. So every single time I click on this, it's doing another 50. You can see that console log is growing by 50 every single time. So if I replace it with the memoized version, it's only doing it once every single time. So that's not only saving on the computation of the Fibonacci number, but also on the rendering of the DOM nodes as well. It's doing some help under the hood there. JSX allows you to use JavaScript to control the logic flow and the templates. However, without a virtual DOM, naive use of things like array.prototype.map would wastefully recreate all the DOM nodes on every update. Instead, it is common for reactive libraries to use template helpers. And Solid, we wrap them in components. Okay, so because Solid doesn't have a virtual DOM, React would say, okay, your array has changed. You used to have 3 elements in your array, but now there's 5 elements, and one of them is a completely different element. It knows how to compare those 2 arrays and only update the things that changed. So it's like doing some diffing for you. SolidJS doesn't have that virtual DOM. It's not doing that diffing necessarily in the same way. So because of that, it's wise to use these other helpers to make sure that you're not re-rendering unnecessarily. The most basic control flow is conditional. Solid's compiler is smart enough to optimally handle ternary and Boolean expressions. However, often it is more readable to use Solid's show component. So this is a bit of a helper thing called show. In the example, we would like to show only the appropriate button that reflects the current state, whether the user is logged in. Update the JSX to this. So we'll replace this. That. Comment this out. Comments don't work like that in here, apparently. So we'll just remove this for now. Comment out here. All right. So this is saying instead of just having a log out and log in button, we say when it's logged in, show the thing inside of it, the child, which is this log out button. And then you can provide a fallback. So this is an alternative to saying like a ternary or an if. So if I say log in and click it, now it says log out. So it's just kind of toggling between the 2 of them. Now you can do this without the show helper by just saying logged in. If that's true, then I want to show the first one. If it's false, I want to show the second one. That's right. This comment doesn't work in there. So we have the same thing happening without the show helper. You don't need the show helper, but it's just something that they provide to make things perhaps a little bit more readable. Like without without really knowing this is a turning operator or what it's doing, this may be a little bit confusing. Like, why are we showing both a login and a log out button at the same time? This one's more explicitly saying, like, when this is true, do this one. Otherwise, the fallback, use this one instead. Control flow. So again, you can just use a regular JavaScript for loop here, but they give you another thing to use instead. The for component is the best way to loop over an array of objects. As the array changes, for updates or removes items in the DOM rather than recreating them. Okay, so I kind of am a little bit wrong when I say that you can just use a for loop. You could, but you're losing some of the optimizations on the DOM diffing that SolidJS will do for you if you just use a for loop. So if you use a for component instead, it does a little bit of that diffing and make sure that only the DOM nodes that need to be updated are actually updated. So let's change out this. It says, let's look at an example. There's one prop in the for component each where you pass the array to loop over. Then instead of writing nodes directly between 4 and 4, you pass a callback. This is a function similar to JavaScript to map callback. For every element in the array, the callback is called with the elements as a first argument and the index as a second. You can then make use of those callbacks, which should return a node to be rendered. Notes that the index is a signal, not a constant number. This is because for is keyed by reference. Each node that renders is coupled to an element in the array. In other words, if an element changes placement in the array, rather than being destroyed and recreated, the corresponding node will move to and its index will change. That's pretty cool. All right, so I believe we need to change the UL there. Put it inside there. And this is for each one of the things in cats. It's going to render this list item with a link to a cat, apparently, video of a cat. So this is how we looped over it with a for. What this is saying is that, let's say I moved this guy over dynamically, of course, not by in the code, but dynamically this array was rearranged. This for loop is smart enough to know that I don't need to actually delete that node. I could just move it. It actually finds it in the DOM, figures out where that node is, yanks it out, and puts it in the correct place. I don't believe React does that. React would actually just be like, okay, the array changed, and this thing doesn't seem to be in the right place. I'm just going to re-render this whole block of stuff. I'm not entirely sure. Don't quote me on that. But, Solid is doing some smarts for us to make it performant under the hood. Control flow and indexes. You now know how to render lists with for, but Solid also provides index components, which will cause less re-renders in certain situations. So this is to be used with, in replacement of for, I suppose. When the array updates, the for component uses referential equality to compare elements to the last state of the array, but this isn't always desired. In JavaScript, primitives like strings and numbers are always compared by value. When using for with primitive values or arrays of arrays, we could cause a lot of unnecessary rendering. If we used for to map a list of strings to input fields, that could edit each. Every change to that value would cause the input to be recreated. Okay. So let's try doing this. We'll go back and copy this for thing. Let's see the difference between using for and index here. Oops. I think that wants me to solve it first. Okay, here it is. All right, so similar to the last one, I could use for here, and this is the same code segment that was used there. But this is saying the index component is provided for these cases as a rule of thumb when working with primitives, use index. All right. So here, basically it's the same thing. You're just using index instead of for. Everything else looks the same. The one thing I do see that's different here is instead of saying cat dot name for the for, this is cat calling it as a function dot name. All right, so I'm just going to copy this and see how it changes here. Okay, so it produces the same result as expected. But what this is saying is that if you're actually referring to primitives, index is better than for. except this time the item is the signal and the index is fixed. Okay, all right, so basically before using for, my guess is, so cat right here is the signal, which means that it has to be called as a function. Here, index was a signal, which is why it had to be called there with a for. So basically it's, which one are you using to compare stuff? Are you using the element itself, or are you using the index to compare things together? So that's the difference between for and index. Index uses, ironically, they're kind of flip-flopped. Index uses, index means that the index is fixed and the item is a signal. For means the item is fixed and the index is a signal. It's using the whatever is the signal is the part that's being used to comparison and diffs. So, well, I hope this was kind of cool to dive into. I enjoyed learning a little bit about signal. Hopefully this was somewhat beneficial, somewhat helpful to all of you guys. Do you guys have any questions on what we went over so far? What are your thoughts on signal so far? Or sorry, not signal, SolidJS.
See a lot of similarities to React.
Yeah.
Ton.
Have you used much of React, Doug? Or
No, I've done a few tutorials and did one project of my own. So I just as I was getting familiar with it, I kind of moved away from it.
Cool.
But enough to recognize similarities with Solid.
Hmm. Yeah, it's really interesting. You know, I'm curious to kind of go into it a little bit more myself and see how it compares to React, and in terms of the feel and ergonomics of coding, but also in performance as well. I like the fact that it kind of tries to feel like React, while under the hood taking some shortcuts to achieve some better performance. So not having that virtual DOM is pretty big in terms of reducing the size of the package and how it will perform. There's not as much JavaScript running. Under the hood, it's basically just doing a bunch of jQuery for you, right? So it's like yanking DOM nodes and moving them around rather than keeping a whole copy of your whole application virtually. So it's pretty cool. Neat. Any other thoughts on Solid? Is this something you would want to see more of, or?
I'm most excited to do the problem and solution things.
Yeah, the coding challenges.
And I'd like to see some, I mean, because I'm focused on React, I'm sort of selfishly more interested in seeing that, as well as vanilla JavaScript, just because, I mean, where I am in learning and whatnot. But it's incredible to see other languages and products in a way that are so similar, you know, to know that the knowledge transfers between them so easily. It's pretty interesting.
Yeah, for sure. I think certain topics don't always translate quite as easily. Solid, of course, is meant to be a nice translation from React. But if you try and go from React to Angular, something like that, it's not exactly a clean translation all the time.
So it'll be interesting to maybe look into those in view.
Yeah. Are there any frameworks or other tools that you're interested in taking a look at for next time?
Redux.
Redux, that's a fun one. It's a little bit of a pain.
Yeah, I'm interested in any of them because honestly, I'm more at a basic JavaScript user, so all the frameworks are kind of new to me.
Sure. Doug, particularly for you as a user of jQuery or things like that, two things that I've recently heard of that are kind of like jQuery competitors or alternatives. I think one of them is called Cache DOM or something like that. It's just called Cache. Unfortunately, with such a simple name like that, it's hard to find, but I can post a link to it in the chat real quick here. And then the second one, which I just saw in like a Hacker News article today, is Umbrella.js. And so both of these are meant to be tiny in comparison to the size of jQuery, but they do a very similar sort of thing. The reason why cache is called cache actually is because it uses the $sign like in jQuery. So it's like, money, the money sign.
Oh, I assumed it was cache, CHE.
Right, that's cache, CASH. It's a little pun. Us developers love puns, wordplay. Okay.
Cool. I'm going to go to both those links right now, just so I have them.
Sure. Yeah. I haven't looked in. I've looked into cache a little bit because at one point I was doing some more low-level DOM manipulation stuff. But I haven't taken a look at Umbrella.js. It's interesting though. Cool. All right. Well, thank you guys for joining. So glad that someone showed up to our first JavaScript meetup for the year. So
Thank you for hosting.
yeah, thank you. Well, look forward to seeing you guys next month.
Where are you're going to post the problem set in the Slack?
Yep. I'll post that in the JavaScript channel. And then we'll meet. We're usually JavaScript meetup is the third Tuesday of every month. So we'll continuing doing that schedule.
Good deal.
All right. Have a good evening, guys.
All right. Good night.
Bye.